Okay, can you guys hear me? Did anybody have any questions to get started with? Okay, then today we're going to take a look at section 6.3, which is about double angle and half angle identities. So first we're going to see what those identities are, and then we're going to take a look at some examples. So we already know that the sine of A plus B is equal to the sine of A times the cosine of B plus the cosine of A times the sine of angle B. So we're going to use that to figure out the sine of 2A. And 2A is just A plus A. So we're going to use A in both spots. So the sine of 2A is the sine of A plus A, which is equal to the sine of A times the cosine of A plus the cosine of A times the sine of A. Okay, so both angles were A, so I filled in A's for both angles. So notice these are really the same thing, right? And so what we end up with is 2 times the sine of A times the cosine of angle A. Does that make sense? Okay. Next, we're going to look at the cosine of 2A. So we've got the formula for the cosine of angle A plus B. And we're going to use that to help us figure out the cosine of 2A. The cosine of 2A is sine of A plus A. So both angles will be A. So we get the cosine of A times the cosine of A minus the sine of A times the sine of A. So we can write that as the cosine squared of A minus the sine squared of A. Does that make sense? Okay, so now we have a formula for cosine of 2A. Now we're going to have a couple other ones because we know cosine squared of A is equal to 1 minus sine A. So we could change this into 1 minus sine squared of A minus sine squared of A. So I have 1 minus sine squared of A minus sine squared of A. That's going to give me 1 minus 2 sine squared of A. So that's one of my formulas. Okay. So all I did up here was I replaced cosine squared of A by 1 minus sine squared of A. On the other hand, I could have replaced sine squared of A by 1 minus cosine squared of A. So let's see what we get if we do that. So we're going to take cosine squared of A minus sine squared of A. And this time we'll leave the cosine squared the way it is. So we have cosine squared of A minus 1 minus cosine squared. So we're going to get cosine squared A minus 1, and then we're subtracting a negative, so we'll end up adding. Okay, so we end up with 2 cosine squared of A minus 1. So that's the other version of the formula. So we have 2 cosine squared of A minus 1. Okay, so we've got 4 different formulas. We have one formula for the sine of 2A, and then we have 3 different formulas for the cosine of 2A. We've got cosine squared A minus sine squared A. We've got 1 minus 2 sine squared of A, or we have 2 cosine squared of A minus 1. Okay, next we're going to take a look at the tangent of 2A. So one thing that we can do, because we know that the tangent of A plus B is the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. So we can do what we did up above. We can say the tangent of 2A is the tangent of A plus A. So that's going to give us the tangent of A plus the tangent of A over 1 minus the tangent of A times the tangent of A. So if we simplify that, we have 2 times the tangent of A on top. And then on the bottom, we have 1 minus the tangent squared of A. Did anybody have any questions so far? Okay. So now we're going to take a look at an example. So we have an angle X that's between pi radians and 3 pi over 2 radians. So it's in quadrant number 3. And we know the cosine of that angle is negative 8/17. And we want to figure out the sine of 2 times angle X and the cosine of 2 times angle X. Right? And we know our formula for the sine of 2x, it's 2 times the sine of x times the cosine of x. And we do know the cosine of x, but we don't know the sine of x. So one thing we're going to need to do is figure out what's the sine of x. And to do that, we're going to use sine squared x plus cosine squared x equals 1. So we have sine squared of x plus, and then we're going to take negative 8/17 and square that, and that has to equal 1. So we know sine squared of x plus 64, because 8 squared is 64, over 289 is equal to 1. So that means that sine squared of x is equal to 1 minus the fraction 64 over 289. So sine squared of x is equal to, well, we need a common denominator. We're going to have 289 over 289 minus 64 over 289. So sine squared of x will be equal to 225 over 269. And now we can go ahead and figure out sine x. All right. We have 2 possibilities. It's either the square root of that number or negative square root of that number. And because we're in quadrant 3, the sign will be negative. So it's going to be negative the square root of that number. Oops, at some point I changed it to 289. That should be 289. So we know sine of x is equal to negative, and this is going to be 15/17. The square root of 225 is 15, and the square root of 289 is 17. So now we know sine of x, and so we can go ahead and use the formula to find the sine of 2x. So we have 2 times negative 15/17 times negative 8/17. And that ends up being 240/289. Oh, okay. Okay, so the negative. Why did we use the negative? Okay, we've got a number squared equals 225/289. There's two solutions to that equation. It's either the positive square root or the negative. And because we're in quadrant number 3, sine is negative. Okay? Remember, sine is going to be the y coordinate if we're on the unit circle, and y is negative in quadrant number 3. Does that make sense? Okay. All right. Thank you for asking. Okay. So now we figured out the sine of 2x. We also want to find the cosine of 2x. We've got different formulas to choose from. Let's see what happens if we use the first formula where we use cosine squared minus sine squared. So we're going to take that negative 8/17, that's the cosine, and square it. And then subtract the sine. What was the sine again? That was negative 15/17, and we need to square that number. So we have 64/289 minus 225/289, and that makes a negative 161/289. Does that look all right? So the cosine is negative, but the sine is positive. Okay. Let's see what would happen if we chose one of the other formulas. So the cosine of 2x, one of our other formulas is 1 minus 2 times sine squared of x. So we could do 1 minus 2 times, and then the sine of x, that was the negative 15/17, and we're going to square that number. So we have 1 minus 2 times 225/289. We have 1 minus 2. Okay, and I need to go ahead and multiply that together. And that gives me 450/289. And then I'll get a common denominator. So that'll be 289/289 minus 450/289. And that gives me negative 161/289, which is good because that's the same answer that I got when I did it the other way. Okay, so it really doesn't matter which formula you choose, you're going to come up with the same answer either way. Any questions on anything? Okay. For the next one, it says to verify that the sine of 3x ends up being equal to 3 times the sine of x minus 4 times sine cubed x. So I thought of 3x as being x plus 2x. And now I'm going to use the formula that we had right up here for the sine of a plus b as being the sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. So that'll be the sine of x times the cosine of 2x plus the cosine of x times the sine of 2x. Okay. And we have some formulas for the cosine of 2x and the sine of 2x. So I'm going to go ahead and use my formulas. So I get the sine of x times, I'm going to use the cosine squared of x minus the sine squared of x. And then I've got cosine x times, and then my formula for sine 2x is 2 times sine x times cosine x. So now I'm going to go ahead and multiply out down here. I'm going to distribute. So I end up with sine x times cosine squared of x minus well, let's see, I'm going to multiply sine x times sine squared x. So that's going to end up giving me sine cubed of x. Does that make sense? I'm multiplying sine x times sine squared. That gives me sine cubed. And then down here, I'm just multiplying cosine x times 2 sine x times cosine x. So that gives me 2 sine x times cosine squared of x. Does that look okay to everybody so far? Okay, so I'm looking at the top here. I want to end up with 3 sine x minus 4 sine cubed x. I've got a sine cubed. Now here, I've got a cosine squared. And here I've got a cosine squared. And I don't want to have any cosines in my answer at all. So I need to think, how could I get rid of having a cosine squared? Well, remember that sine squared x plus cosine squared x is equal to 1. So that means that cosine squared x is the same thing as 1 minus sine squared. And the other thing I'm noticing is that I've got this sine x times cosine squared x, and this is the same thing except I have 2 of them. So I can put them together, okay? I'm gonna collect my like terms. These are like terms. So that's actually 3 sine x times cosine squared of x minus sine cubed of x. Does that make sense? So these are really the same sort of thing, and I can combine them together. I've got 1 copy here and 2 more copies, so that makes 3 copies. And then because this is cosine squared x, I can replace cosine squared with 1 minus sine squared. So this is sine x times 1 minus sine squared of x minus the sine cubed of x. Does that look okay? Okay, and now I'm going to distribute. I'm going to multiply the 3 sine x, first with the 1, and then with the sine squared x. So this will give me 3 sine x minus 3 sine cubed x minus sine cubed x. I'm almost there. I've got everything down in terms of signs now. I've gotten rid of all the cosines. It doesn't quite look like the answer I want it to look like. I do have the 3 sine x. And if you look at these, this is 3 sine cubed, and this is sine cubed. So those are like terms that we can collect together. So this will give me 3 sine x minus 4 sine cubed of x. Did anybody have any questions on that one? Okay. Next, we want to verify that 1 minus the cosine of 2x divided by the sine of 2x will be equal to the tangent of x. So we're going to start with the more complicated side, the left-hand side. And we're going to use the double angle formulas. So the first one I'm going to write as 1 minus, and then I'm going to use the 1 minus 2 sine squared of x. And then on the bottom, I'm going to replace sine of 2x with 2 sine x cosine x. Okay, so on the top, if I got rid of the parentheses, I'd have 1 minus 1. Those would go away. And then I would have minus a negative 2 sine squared x. So the ones are going to go away. And because I'm subtracting a negative, it'll turn into a positive. And I have 2 sine squared x. And now let's see, we can cancel out the 2's. And on top, I've got sine squared x. And on the bottom, I have sine of x. So I can cancel a sine x on the top with one of the sine x's on the bottom. And so on the top, I only have 1 sine x left. And on the bottom, I'll have cosine x left. So I end up with sine x on top and cosine x on the bottom. And sine x divided by cosine x is tangent of x. So we were able to do that. Okay. Anybody have any questions? Okay, you might be wondering about why did I choose this formula for the top, right? On the bottom, I didn't have any choice. There's only one formula for the sine of 2x. I could have used a different formula on the top. Let's see what would happen if I had used one of my other formulas on the top. So the top, I could have used cosine squared of x minus sine squared of x. That's one of my formulas for the top. And then the bottom would still have been the 2 sine x cosine x. Oops, I'm sorry, I needed a 1 minus out in front of that. And on the bottom, I would have still had the 2 sine x cosine x. So let's see what we would have ended up with now. We would have 1 minus cosine squared of x. And then we're subtracting also, oops, but we're subtracting a negative, so we'll be adding sine squared of x. And then the bottom would have still been the 2 sine x cosine x. So this is a lot messier if we try to do it this way. And what we want to end up with, having signs on the top to cancel with the signs on the bottom. So in order to make that happen, we would then want to replace this 1 minus cosine squared by sine squared. So it's a lot more work if we try to do it this way. So we would have sine squared x on top plus sine squared x. So we'd have 2 copies of sine squared. I'm running out of space. I'm just going to put a 2 out in front and get rid of this. And then we would have the 2 sine x cosine x on the bottom. So we've really gotten it back to this point. We've just done more work to get there. Okay, so there's no wrong answer, but there's answers that can save you some work. Next up, we're going to take a look at something called the power reducing formulas. So we have a formula for cosine of 2a, which is 1 minus 2 sine squared a. Okay, so that was one of our formulas. And I want to take this and solve it for sine squared. Okay, so I can do cosine of 2a minus 1 equals negative 2 sine squared. Okay, so I've subtracted the 1 away from both sides. And then what I can do is I can divide both sides by the negative 2. So I will have the cosine of 2a minus 1. I'm going to divide that by negative 2. And that's equal to the sine squared of a. If I divide it by a negative 2, I can switch the ordering on the top. I can write that as 1 minus the cosine of 2a divided by 2 equals the sine squared of a. That look okay so far? Okay, and then we have our other formula, the cosine of 2a is equal to 2 cosine squared a minus 1. And I want to take this formula and solve for the 2 cosine squared. Okay, so for this one, I'm going to add 1 to both sides. So I've added 1 to both sides now. I've got 1 plus the cosine of 2a is equal to 2 times cosine squared of a. And then I'll divide both sides by 2. So I have 1 plus the cosine of 2a divided by 2 is equal to the cosine squared of a. So I've got these 2 formulas. Right. I've got a formula for the sine squared of a and a formula for cosine squared of a. And now I'm going to use those to find a formula for tangent squared a. And I know that tangent squared a is equal to sine squared of a divided by cosine squared of a. And I know that sine squared of a is equal to 1 minus the cosine of 2a divided by 2. And I know that the cosine squared of a is equal to 1 plus 1 plus the cosine of 2a divided by 2. Okay? So I've got a fraction on top and a fraction on the bottom. And one thing that I can do when I have fractions is multiply the top and the bottom by the same thing. So I'm going to multiply the top and the bottom by 2. And when I do that, it'll get rid of the 2's. So I've got 1 minus the cosine of 2a on top and 1 plus the cosine of 2a on the bottom. Okay. So that's a formula for tangent squared of a. Did anybody have any questions at this point? Okay, so those were the power reducing formulas. Next up, we have what are called the half angle formulas. And we're just going to use the formulas from up above. So here's a formula. We just saw that a second ago. We saw that sine squared a was equal to 1 minus the cosine of 2a over 2. Instead of using the letter a, I'm using the letter x down here. But it's just sine squared x is 1 minus the cosine of 2x over 2. And so I'm going to take the square root of both sides. And that gives me sine x is equal to plus or minus the square root of 1 minus the cosine of 2x over 2. And then the next thing I'm going to do is I replace x with a over 2. Okay? So the sine of a over 2 is just plus or minus the square root of 1 minus the cosine of a over 2. And if we do that, so we have x equals a over 2. X is equal to a over 2. If I multiply both sides by 2, I have that 2x is equal to a. So basically, I'm just doing a change of variables. I'm just calling something by a different name. So x is going to be called a over 2. Okay, so this x turns into a over 2. And then 2x turns into a. Okay, so I'm just changing up the names of the variables. And then next we do something very similar with cosine. So the cosine of a over 2 is going to be plus or minus the square root of 1 plus the cosine of a over 2. And the tangent of a over 2 is plus or minus the square root of 1 minus cosine a over 1 plus cosine a. There are also two other formulas for the tangent of a over 2. They're the sine of a over 1 plus cosine a, or 1 minus cosine a over sine of a. Okay? So there's 3 different formulas for the half angle for tangent for a over 2. Let's take a look at a quick example. We're going to figure out the cosine of 5 pi over 8. So the first thing I did was I thought about, well, where will 5 pi over 8 be? I know that pi over 2 is right here, which is 4 pi over 8. And pi, oh, this is a typo, pi is equal to 8 pi over 8. Pi is 8 pi over 8. So 5 pi over 8 will be in quadrant number 2. Five pi over 8 is in quadrant 2. And 5 pi over 8 is equal to 5 pi over 4 divided by 2. Remember, dividing by 2 is the same as multiplying by a half. So this is going to be my a over 2. A over 2 is 5 pi over 8. And A is 5 pi over 4. Is that okay? So I'm going to use my formula for the cosine, and it says the cosine is plus or minus 1 plus the cosine of A. My A is 5 pi over 4 over 2. Okay, I'm using the negative sign. How did I know to make it negative? It says plus or minus in the formula. Well, because I know 5 pi over 8 is in quadrant 2. Whenever you have an angle that's in quadrant 2, the cosine is negative. So that's how I knew to use the negative sign there. Okay, so you do need to figure out whether to use the negative or the positive. All right, so then next, I found the cosine of 5 pi over 4. And the cosine of 5 pi over 4 is minus the square root of 2 over 2. Okay, so I figured out the cosine of 5 pi over 4, and I plugged it in. And then I'm going to simplify. So I want to figure out, what do I get on the top of this fraction? In order to figure that out, I'm going to find a common denominator, which is 2. So I have 2 over 2. And then I'm going to subtract the square root of 2 over 2. Okay. And so now I'm going to end up with 2 minus the square root of 2 all over 4. Okay? Because this fraction is over 2 and this fraction is over 2, and I'm dividing the whole thing by 2. So I can put the entire top of this over 4. And I know the square root of 4 is 2. So I've gone ahead and taken that part out of the square root. So I can simplify it just a tiny bit and end up with 2 minus the square root of 2 underneath the square root. Oh, okay. How did I get the cosine of 5 pi over 4? So I was using this formula right here, the cosine of A over 2. Okay, my A over 2 is 5 pi over 8 is equal to plus or minus, and I figured out I needed to use the minus sign, the square root of 1 plus the cosine of 5 pi over 4. Okay, and so that's how I knew to do this. I think another question might have been, how did I know that the cosine of 5 pi over 4 was the square root of 2 over 2? To do that, I was basically using my unit circle. 1 pi over 4 is here, 2 pi over 4 is here, 3 pi over 4 is here, 4 pi over 4 is here, the negative x-axis, and 5 pi over 4 is in quadrant number 3. So its cosine is negative square root 2 over 2. And yes, this would be your answer. Okay, if you were asked to find the cosine of 5 pi over 8, this would be your answer right here. And I think this is a good stopping point for today. We'll finish this up tomorrow. Remember, you do have some homework problems on MyLab, and you have 2 quizzes now. One quiz is due on Friday, and the other quiz is due on Monday. So please make sure to get into MyLab and work on those. Did anybody have any questions about anything? Yep, I did get it. Thank you, Christian.